Welcome to the Deep Dive, your shortcut to being, well, really informed. Today, we're diving headfirst into something pretty mind-bending, a concept you hear everywhere. The multiverse.
Right, it's huge. Sci-fi, but also serious science talks.
Exactly. But for this deep dive, our source material takes a, let's say, provocative look. It really questions how these big ideas get discussed, how they're defined in science.
Yeah, that's our mission today. We're using this source to kind of pull back the curtain a bit.
Yeah.
We want to explore how something like, a simple definition or even funding, how that can shape the whole conversation, especially with grand stuff like, well, infinite universes.
Okay, so let's unpack this. The source kicks off with this observation that feels spot on.
Which is?
How people talk very easily about a multiverse or multiverses, even infinitely many multiverses. It just rolls off the tongue.
Like it's everyday stuff, which it really isn't. And the source says this ease, this casualness, it often comes from not using definitions properly or using sloppy definitions, as it puts it.
Sloppy definitions, okay.
And it suggests physicists can kind of get away with this because they always refer to mathematicians for the definitions.
So it's like that's their department, not ours, that kind of thing.
Something like that, yeah. It sets up an interesting sort of dependency.
Okay, and here's where it gets really interesting. The source shifts gears.
How so?
It makes this rather controversial comparison. It says, promises and spectacular results always attract money.
Okay. Standard enough, maybe.
But then it draws a parallel to, wait for it, the old alchemists.
Alchemists, seriously?
Yep. Saying they never disappeared, promising gold, but, using the money for their own research, their own food in the meantime.
Wow, okay, that is a bold comparison, linking modern science funding to alchemy.
It's definitely designed to make you think.
And it doesn't stop there, right? It extends this idea to mathematics itself.
It does.
The source claims, pretty provocatively, that if math is treated less like a useful, a man-made tool.
And more like something holy, the language of the universe.
Exactly. Then it starts functioning like just another religion.
Another religion, attracting belief, and importantly, money.
Right. And the source adds that this is maybe not what we want to hear, but is probably closest to the truth.
That's quite a statement. Comparing math itself to a religion, if it's not seen just as a tool, it really doesn't pull any punches, this source.
Not at all.
So if there's this underlying financial current, this pressure, what happens when these big money-making ideas are actually challenged?
Well, the source suggests something pretty uncomfortable.
Which is?
That most scientists and mathematicians will, of course, ignore any threat to their income.
Just ignore it, flat out.
That's the implication. It raises a huge question, doesn't it?
It really does. Why ignore it? What are the reasons given?
The source gives two main reasons. First, maybe the doubt is just dismissed as, too stupid to reply to.
Okay, standard academic dismissal, perhaps.
But the second one is the kicker. It says sometimes the doubt cannot be dismissed with a scientific reply.
Meaning, it's actually a valid point, scientifically.
Potentially, yes. And the source really zeroes in on this, arguing that asking for a proper definition, for example, is very unpopular.
Why unpopular?
It has to be ignored for the second reason because, and here's the link again, it is a threat to someone's income.
Wow. So a fundamental question about definitions could threaten funding.
That's the argument. And it gives an example to make it concrete.
Like what?
It says, if, for instance, one would doubt the build of a particle accelerator being very expensive, questions can easily be ignored.
Because questioning the accelerator questions the massive investment behind it.
Precisely. It's easier, the source implies, to just brush the question aside.
That's an uncomfortable thought, that real scientific questions might get sidelined for, well, money.
Definitely unsettling.
So how is this ignoring actually done? What are the strategies? The source talks about lines of defense, right?
Yeah, it outlines a few methods scientists might use to, deflect or ignore these inconvenient doubts.
Okay, like what?
First, they might claim the doubt is not raised scientifically.
Meaning,
it is not written according to all the rules that scientists use to look scientific. Not following the proper format, maybe not peer-reviewed in the right way.
So a procedural dismissal. Got it. What else?
Another tactic is just to dismiss the person raising the doubt.
Oh.
By saying they're not competent or not qualified. Attack the messenger, not the message.
Right, classic deflection.
And if those don't work, if the doubt persists,
then what?
The source says the last resort is to try and raise doubt on the doubts. Basically, muddy the waters.
So it sounds like a kind of playbook for protecting the status quo, maybe even creating an echo chamber.
That's certainly one interpretation of what the source is suggesting here. Inconvenient truths might struggle.
So, okay, zooming out. What does all this imply for the foundations of these big theories, like the multiverse?
Well, the source makes another sweeping claim here.
Go on.
It argues that physics is full of them, meaning loose definitions. And why?
Right.
Because, it says, the foundations of mathematics has flawed definitions of number, infinity, and continuity.
Whoa. So it's saying the problem goes right down to the mathematical bedrock. Flaws in how we define basic concepts like infinity.
That's the assertion, that these foundational ambiguities, these maybe flawed definitions in math, allow for or even create wiggle room higher up in complex physics theories.
Which could lead back to those sloppy definitions we started with.
Exactly. It's suggesting a potential root cause.
And connecting this to the bigger picture, does the source link this back to physics itself, beyond just the math definitions?
It does. It also claims that the foundations of physics are based on symmetries and laws instead of on the underlying material or materials and its properties.
Okay. What's the significance of that distinction? Symmetries versus underlying stuff?
Well, it loops back to that financial thread again.
Ah.
The source claims it's simply easier to make money of symmetries and the current status quo than of some underlying reality in a new situation.
So focusing on abstract laws and symmetries might be more fundable than digging into potentially disruptive ideas about what matter actually is.
That's the implication. A preference for the established,
Yeah.
perhaps more mathematically elegant, and crucially, the funded pathways over rocking the boat with foundational challenges.
Okay, this source paints a pretty challenging picture of how science, or at least parts of it, might operate. Given all these critiques about definitions, funding, ignoring doubts, does it offer any way forward? A solution?
You'd offer something, yeah. Maybe less of a solution and more of a pragmatic suggestion.
Which is?
It says maybe it is best just to do both.
Do both. Both
But allow people to, talk about universes and information in the matrix as building blocks.
Mm-hmm.
Let those big, maybe loosely defined ideas flourish.
Okay.
And do the proper research alongside. Do the rigorous foundational work, too.
Ah, so run things in parallel. Let the speculative stuff happen, but also make sure the fundamental work gets done.
Exactly. The idea seems to be that perhaps no person feels threatened that way. It avoids direct confrontation, maybe allows different approaches to coexist.
Interesting. A path of parallel exploration, not necessarily forcing a choice between grand speculation and foundational rigor.
Seems to be the idea.
So, wrapping this up, the main takeaway from our deep dive into this source is really a challenge, isn't it?
I guess so.
A challenge to look beyond the surface, to consider these often hidden influences. Things like how we define terms, where the money comes from, the social norms within science.
Right, how all that shapes the scientific conversation, especially around these huge, almost philosophical concepts like the multiverse.
It really underscores the need for critical thinking, wouldn't you say?
Absolutely. The source pushes us to question not just the answers science gives, but the questions it asks, the definitions it uses, and, even the motivations behind certain theories.
Looking at the whole ecosystem, really, from the funding bodies down to the philosophy of math.
Exactly. The whole picture.
So here's something for you, our listener, to chew on. What stands out to you? Could the way we accept certain big scientific ideas, especially these vast ones like multiverses, could that be more tied up with practical stuff like funding streams and just how disciplines work than we usually admit?
It definitely gives you food for thought.
It really does. Thanks for joining us on this deep dive. Keep questioning, keep exploring that fascinating space where science, definitions, and, human behavior all intersect.